Welcome to another broadcast from Casa de Brady. You're in my dining room. It's Methy with a lot of math textbooks. All right, we are starting Unit 3. We're looking at Chapter 6, and we are talking about simplifying radicals. Not only are you going to do the good old-fashioned square root, you're going to do a cube root, you're going to do a fourth root, and you're even going to be able to take care of something that looks like x to the 1/2 power. That's what I meant to draw. X to the 1/2 power. So those are rational exponents. By the end of the unit, you'll be there. Okay, first thing we need to do is talk about our parts. We've got some vocabulary we've got to learn. I want you to notice that the index is this value that is sitting outside the check mark. So I've got an index here, and an an index here. Let me fix that. Next thing I've got is a radicand. A radicand is some number that is underneath my radical symbol. So these are my radicands. And if we come down and we talk about what we've got, my index here, when my index is invisible, it's the number 2. My index here is 3 for a cube root. My index here is 7. I'm looking for the 7th root. Next, my radicand, the number underneath the radical symbol. My radicand is 9, my radicand is 216, and my radicand is 128. So whenever I talk about the radicand, we're talking about the number that's underneath the square root symbol. Okay. Next, simplifying. How many times have you heard me say simplify? Ooh, I'm not done. So we're going to talk about simplifying radical expressions. Radicals are in simplest form when the following conditions are met. When the radicand has no nth power factors. You'll see that in a minute. When the radicand is not a fraction and there's no radical in the denominator. That's when things are simplified when we're talking about radicals. What does it mean for a radicand to be a fraction? Remember, a radicand is the number underneath the square root. So I cannot have 1/8 underneath a radical. That is not in simplest form. We've got to take care of that. The other thing I can't have is I can never, ever, ever have a radical in the denominator. If we have a radical in the denominator, I don't know, that's really bad juju. We're going to have to figure that out. You're going to learn some strategies to fix that. So these are two cases that are very bad. All right, let's talk about simplifying and what I meant when I said nth root factors. So here's the square root of 9. I know it's the square root because there's an invisible 2 there. I know that 9 is really 3 squared. And so when I talk about simplifying, I can't have any nth root factors. Notice my index is 2 and I've got 3 squared. Well, that can't be. I should simplify this. Literally, the square root undoes the squaring of a number. It makes that all go away and just the number 3 comes out. Same thing over here. I'm looking for the cubed root of 8. Well, I know that 2 to the 3rd power is the number 8, and I cannot have any cubes, any number to the 3rd power underneath my radical. Well, what's really nice is the cube root completely gets rid of raising anything to the 3rd power, so that's number 2. Same thing with the 4th root. 2 to the 4th is 16. When I take the 4th root of that, I get the number 2. When I take the 5th root of any number raised to the 5th power, I get a. So we need to simplify that. So if you ever have the square root of 25, you always have to show me that it simplifies to 5. All right, next, that word root that I was talking about. So what we've got here with roots, I can say that 2 is the 5th root of 32 because 2 to the 5th is 32. I can also say that 3 is a 4th root of 81 because 3 to the 4th is 81. I want you to know that this means 3 times 3 times 3 times 3. That equals 81. I don't want you to say 3 times 4. Okay? 4 is an exponent, which means I multiply this number by itself this many times. So don't get confused with that. So in general, for all numbers, if I have a to the nth power equals b, then I can say that a is an nth root of b. And if you need an example, go back and think about it. 2 to the 5th power is 32, so I can say that 2 is the 5th root of b. Okay, let's talk about the meat and potatoes. You are going to need to know the list of squares and the list of cubes. So get in the habit of looking for these numbers. 1, 4, 9, 16, 25. Look for your perfect squares. Get in the habit of looking for your perfect cubes, which you should be becoming more familiar with. The other thing that you can do here is in your calculator, under your y equals, you can put in y equals x squared. You can even put in y equals x cubed, and then go to your table. Your table will have a list of all the perfect squares and perfect cubes for you. Okay. What else can your calculator do? Underneath this math button that's right over here, when you click math, it opens up this window with these options. Well, option 4 is the cube root. So you can throw in the cube root of 216, click enter, and it says tell us 6. What happens when I'm talking about the 5th root? Well, we're going to enter that in a little different, and I'm going to show you in class. But really what you need to do is you need to type 5 first, then you're going to click math, then you're going to scroll down and click option 5, so you're going to do x root, you're going to hit enter, and then you're going to come back and put in the number 32. Then it'll spit out a number 2. It's a little trickier, but that's how you find that out. All right, let's start simplifying. What is the square root of 81x to the 4th? First thing I want you to do is see if 81 is a perfect square, and it is. What's the square root of 81? It's 9. Now, what is the square root of x to the 4th? X to the 4th looks like this, and what I'm looking for is groups of 2, or pairs. So, how many sets of x times x do I have? I have 2 sets, so this simplifies to x squared. All right, let's try 4 times the square root of 78a cubed. So I look over here, and 78 is not in one of my perfect squares. But maybe if I divide out a number, one of these will pop out. So 78's even. I'm going to divide out a 2. And when I divide out a 2, I get 39. Well, 39's not in my list, but I know that 39 can be factored into 3 times 13. So the numbers I'm looking at are all in this bottom row. 2, 3, 13 are prime numbers. I factored him. None of these are pairs. So 78 is as simplified as he's going to get. However, a cubed means I have a times a times a. Since I'm looking for the square root, I can pull out 1a. So my answer is going to be the original 4 that's in front of my problem. I'm going to take out one of these a's. The pair of a's comes out as a single. And underneath the radical, I'm left with 78. Leave them as 78a. That is that number simplified. All right. Let's try 8 times the square root of 90a cubed. Well, I know 90 isn't a perfect square, so I'm going to start breaking this down into the first prime number that goes into him is I'm going to say 3 times 30. And I know I can break 30 down into 3 times 10, and I can break 10 down into 2 times 5. So what are my numbers that I'm looking at? At the bottom here, I'm looking at this row. 3, 3, 2, 5. While I'm at it, I'm going to write out my a cubed. So since there's an invisible 2 here, that you have to know that that's what that means, I've got a pair of 3's, I've got a pair of a's. Those guys are going to come out and be written in front of the radical. There's my original 8. I'm going to bring out the 3. Pair of 3's comes out as 1. Pair of a's come out as 1. And what's left? Well, 2 and 5 are left underneath my radical, but let's write those as 10. and I've got 1a. Now we're almost done. You've got to do this multiplication. Everything outside of here, this whole expression is multiplication. 8 times 3 is 24a, and then I've got 10a left underneath the radical. Okay? That's how that one works. All right, let's try a cubed root. I'm looking for 3 of the same number. I know that 216 appears in my list. This is 6 times 6 times 6. A to the 16th. I do not want to write out 16 A's and look for groups of 3, but I will for the first time. So, A to the 16th means I'm multiplying A by itself 16 times. So there's my one group of 3 A's. I'm going to look for A's in group of 3. There's one set of 3, 2 sets, 3 sets, 4 sets, 5 sets. So I can take out 5 sets of A, which gives me an A to the 5th. So let's take care of this 6. Let's take care of an A to the 5th. And maybe we could do a shortcut with the B to the 9th. BBB, 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 1, 2, 3. So I can take out a B cubed. All right, what's left underneath my radical? Just this A. All right, and when you write your answer, I want you to be careful that you know this 3 right here is really the index on the square root. I want to show you a shortcut for this 16. Notice I have 16 A's here. If I divide it by the number 3, that is 5 with 1 left over. So I brought A to the 5th out. I've got A to the 1 left over. This is, I have 9 B's. 9 divided by 3 is 3. How many B's did I bring out? 3. We're going to use that same shortcut with this example. So x to the 12th, let's divide it by 4. That gives me x cubed. Y to the 16th divided by 4 gives me y to the 4th. That's my answer. All of that comes out from underneath the radical. There's nothing left inside. All right, simplest form on this guy. Square root of 96, x to the 8th, y to the 5th. Well, 96 is not in my list. I'm going to take out a 2. 96 is 2 times 48. I'm going to take 48, and I know that 16 times 3 is 48, and I know 16 is a perfect square. So I'm going to do 16 times 3. So that's your 4 times your 4. And then I'm looking at the number 2, and I'm looking at the number 3. So what comes out? 1, 4. And then what's left underneath the radical? 2 times 3 is 6. Now I'm going to come through and take care of this x to the 8th. I'm going to divide it by 2. That's going to give me x to the 4th. And then I'm going to take y to the 5th, and I'm going to divide him by 2. That's y squared, but I have 1 left over. The 1 left over has to stay underneath the radical. And everything on the outside looks like multiplication. Okay? All right, let's see what else I have. Let's look at 7 times the cubed root of 128, b to the 7th. So 128 is not in my list of perfect cubes, but 64 is. And 64 is the cube root of 4. So can I do this? Can I say that 128 is 2 times 64, and 64 is 4 times 4 times 4. So here's my bottom row of numbers. I'm only looking here, and I've got b to the 7th. So b to the 7th divided by 3 is going to be b squared with 1b left over. Okay, 1b left over, and that should just be the letter b. So I'm going to pull out these 4s, and I've got a 7 in front. I've got one of the 4s is coming out. I've got a b squared coming out. And then what is left underneath the number 2 and the letter B? So when I write this, 7 times 4 is 28b squared, and I'm left with 2b, and I've got to go back in and make sure that I write my 3 here so you guys know this is the cubed root. We can't forget about that because that's really important. All right, last example. 5 times the square root of 72, x to the 4th, y to the 6th. I just happen to know that 72 divided by 2 is 36, and 36 is a perfect square. So I'm going to say 2 times 6 times 6. I've got a pair of 6's. That pair of 6's is going to come out. I've got that 5 sitting in front. I'm going to put my radical here. 2's left underneath. What's really nice is x to the 4th divided by 2 is x squared. So x squared comes out. Y to the 6th divided by 2 is y cubed. So he comes out. So when I write this whole answer, this is multiplication out here. This is 30 x squared y cubed. And that, square root of 2. That's what's left over. That's my answer. All right, this is going to be on your entrance slip into class. So be ready to have the answers to these ready to record on a sheet for me when you walk in tomorrow. Have a good night. If you need to go back through, pause, rewind, make sure you get this because all of class you are going to be practicing and doing your homework. All right, we'll see you tomorrow.